Hello and Namaskar. I am Debapratim Ghosh, and in this brief session we are going to be taking a look at the measurement of S parameters in practice, and that relates to the broad subject of RF and microwave engineering. So, after doing this session, you should be able to first explain the principle of the S parameter measurement, and you should also be able to illustrate the working of S parameter measurement systems. So, to say this in a slightly different manner, effectively you will gain an insight into this. What is this? This is a vector network analyzer. So, after this session you should be able to gain a complete insight, or at least some insight into the working of this instrument called as the vector network analyzer, which is the bread and butter of every RF and microwave engineer. The vector network analyzer is also called as VNA for short. So, let us see the principle behind this. To understand the principle, let us go back to high school for a little bit, where you assume that there is a glass slab and a ray of light is incident on that glass slab. So, what happens? You have a reflected wave, a small reflected wave at the boundary of the glass surface, and a transmitted wave which appears on the other side of the glass. So, if you have the knowledge of all of these three waves, that is their magnitude and the phase, you will get some very important information about the properties of the glass slab, right. So, similar is the principle of working of a VNA. So, VNA works on the exact same principle to measure the S parameters. And how does it do that? It does that by making a wave incident at port 1 of the circuit. Now, the circuit is that circuit whose S parameters you want to measure. And second step is, after making the wave incident at port 1, you measure the reflected and the transmitted wave at port 1 and port 2. Notice that the reflected wave appears on the same side as that of the incident wave, and the transmitted wave appears on the other side. So, therefore, the incident wave is at port 1, the reflected wave also appears at port 1 but in the opposite direction, and the transmitted wave appears at port 2. Finally, once you have all these three waves, you calculate the S parameters by taking the ratio of these three waves. Now, let us take a slightly more detailed insight into this. So, let us convert this light wave analogy, which we just saw in the previous slide, into an electrical form. So, the first thing that you need in a VNA is a microwave source or an RF source which generates high frequency sine waves. What do you need next? Next, that wave is sent through a power divider, and that splits it into two equal halves, and one half is sent to the incident wave receiver, which serves as a reference measure that this is the incident wave that will be sent to the port 1 of the circuit whose S parameters we want to measure. Now, our next step will be to send this incident wave onto the circuit, and that is done by the other output of the equal power divider. So, effectively the wave from the RF source is split into two equal parts. One part is used as a reference measure for the incident wave, the other half is the wave that is actually being made incident. So, at port 1 this wave enters the circuit under test. Then what happens? At port 2, this green color arrow indicates the transmitted wave which appears on port 2 and is captured by the transmitted wave receiver. But we are forgetting something, and that is the red colored reflected wave which is coming out of port 1 in the opposite direction as a result of the wave that is incident at port 1. Now, the challenge or the fun lies here. How do you capture the red wave? Effectively, the two waves are there at port 1 on the same side, of this or on the same wire. So how do you capture that signal? You do that by using a device called as a directional coupler. So this directional coupler will essentially couple a fraction of the reflected wave, which is denoted in red color, to a different line. However, notice the word directional. It will couple only the backward wave, not the blue color incident signal, hence the word directional. And once it captures the wave onto the other line, it will send that reflected wave into a reflected wave receiver. Now, one thing to note is that this is just a fraction. The magnitudes are not exact. So therefore, these receivers will capture these waves, but also do some calibration to ensure that you are able to extract the actual wave that was reflected. Next, these outputs from the three receivers, that is the incident wave receiver, the transmitted wave receiver and the reflected wave receiver, are collected and sent for processing and display. Now, as I mentioned earlier, the wave data is in the form of both magnitude and phase. So therefore, you may recall from your digital communication course that magnitude and phase information are often encoded in the form of in phase and quadrature phase signals, and those are the outputs which are taken from all the receivers and they are sent for processing and computation and display. So let's see how. In this block diagram, the circuit that is under the test is the only part that is actually outside of that big VNA box. All the other parts are inside, but the effective circuit and principle is very simple, as we just discussed. Now, two S parameters, that is S11 and S21, can be simply computed by taking ratios in this manner. So S11 is nothing but the reflected wave divided by the incident wave, and S21 is the transmitted wave divided by the incident wave. So if you want to measure the other two S parameters, remember that S matrix is always a square matrix. So if you want to measure S12 and S22, all you need to do is simply take the circuit under the test and reverse the connections. So this particular architecture of a VNA is what is called as a transmission reflection architecture. So in this particular session, we took a peek into the working principle of measurement of S parameters and how a VNA works. There is much more to a vector network analyzer than we have discussed today, and I hope that soon we will be able to have a longer discussion on this. Thank you.